In this video, I'm going to show you how I designed this resin washing tray in Fusion 360 using the shell command, and how I made it have its own built-in sieve using a quirk of FDM 3D printer slicers. Let's get started. How's it going, guys? Angus here from Muse. So some of you may remember this resin washing bath I had when I reviewed the Form 3 back in 2017. That was a fantastic resin printer, very high end. I miss it dearly because I sent it back. But when they sent it to me with this washing station. So this washing station had two different tubs with little built-in trays that you could put the resin part in off the machine and wash the excess resin off in isopropyl alcohol by just agitating it. Then you could take it off and set it aside to cure. Now, unfortunately, that was damaged in shipping. Only one bath was secure, the other one was cracked and leaked, and I've since lost one of the trays after moving to our new premises. So I thought, look, a lot of you guys asked where to buy it, and you can buy it, it's just very expensive, but why buy it when you can design and make your own? What if I could build in a sieve essentially into the actual washing tray for the washing bath for my brand new Resin 3D printers that I'm currently evaluating? Now, this is not aimed at beginners at all, sorry, this is gonna be way too fast paced. If you are new to Fusion 360, check out my CAD for Newbies series, but without further ado, let's get started. Here we are in Fusion 360 with my new resin cleaning tray. Now, what I want to talk about here before I get started is my thoughts on the licensing changes of Fusion 360. Now, some of you may know that they changed things with the startup license, which I was originally on. And look, Muse isn't a startup anymore, it's been going for years, so I just went ahead and bought a yearly license, which was a little bit shy of $400 Australian. You can still use Fusion for free if you're in education, or if you're a hobbyist, or if you are a legit startup and you can prove that you're a startup. But again, I've been going for a while, and I probably could have emailed them, but time is money, and I needed Fusion up and running ASAP. I still believe it's a really powerful tool and really valuable, and I'm still going to be showing my tutorials in it on the channel, but that's out of the way. Let's dive into this resin tray. Now, what I want to talk about here is the shell tool. I've done a lot of Fusion tutorials before, but I've never really covered the shell tool, and it's really critical for designing a part like this. It might look complicated, but it's actually not that bad. Let me roll back and show you how I designed this tray using the shell command to make the final shape. So let's go all the way back to the beginning. Right, we have a block. So this is just a single sketch, which I've extruded up to the right height. So I've got my pair of calipers and I've got this tray. This is just from Bunnings. It's just a 3 litre or 3.1 quart storage tub. And I just use my calipers to measure the inside bottom shape because it's got draft on it. So you've got to make sure it will fit all the way down to the bottom. And basically I got this shape, which I then extruded up. And that's the basis of our resin tray. Now what I did next is I added these cutouts here. And the reason I did that is because it adds strength. So if you just have vertical walls, parts aren't very strong. So you notice with these trays, they add little details, like they indent it here, it's got a lip here. They'll add all sorts of things to add a bit more strength. Otherwise, it would be really floppy and flimsy. So what I've done here is I've just done a sketch. If I can just show you the sketch here, which cuts these little indents out. And the real power of the shell command is that these indents will now be also inside the part of the tray. You don't have to try to model complicated parts using the same consistent uniform wall thickness. Then the next part was a little bit more tricky. I wanted some strength around the bottom lip because this is a earlier version I did, and see, it's still a bit floppy, so I wanted to add some strength here. And I did that using the sweep command, which looks like this. You can see that here. Using the same sketch, I grabbed one of the circles, and what I did is I projected off an offset from the block, and then use that as the path. So a single circle as the profile, that path there, and then it went all around the shape, and then what we ended up with is that nice cutout there. Now, the complicated bit of this was getting the plane for that path in the right location. You see it's perfectly in line with our sketch. It's perfectly going to line up with it. And it's a little bit hard to do the construction geometry in Fusion correctly to do this. So I'll show you the plane that I used for that sketch. And I don't know if this is the right way to do it, but what I did is I used a axis, which then used this cylindrical shape to get an axis, like that. So that is under construction, you go to axis through axes through cylinder, cone, or torus. So we get an axis there, and then what I did is I added a plane at an angle. So this plane here is just dropped in on that line, that axis, and you can change the angle of it if you like, but I just left it flat. And then I did my sketch on that. Now, I don't know if that's the best way to do it. I couldn't really find a way to do a plane that's parallel to a point in SolidWorks. You used to be able to do that, which is what I originally studied. But anyway, that's how I did that, and then we ended up with a shape. Now, the next step is to make it all pretty and rounded. Now, you do this before the shell, but you need to keep in mind that your shell thickness will affect what the inside geometry looks like. You need quite generous radii, because when you offset, those radii become smaller, and if you offset too much, then they disappear, and the shell will fail. So what I did is I did some quite generous fillets. You can see here. So if I right click here, you can see where I added these fillets, and these are 6mm in diameter, and it just adds some nice sort of flowing geometry to make this shape look a little bit nicer versus, you know, those hard edges. So that's what I did there. And then we come to the shell command. So there's two different ways you can use shell. You can shell an object with an opening. So you select a face and it will remove that face and shell the object to make it hollow. Or you can completely hollow an object with no opening by shelling the entire body. So I'm going to show you how both of those work. So select shell here on the top left. And then to shell with an opening, you select the face you want to shell. Now, because it added fillets, you notice it's highlighting the whole thing there. That's not good. It doesn't like shelling things up to the edge of fillets. It wants hard edges. So you can see it can easily shell the bottom face. So let's do that. Let's shell this, and let's do it like 1mm or something. Simple as that. So what we've got now is a uniform 1mm offset all around the object inwards with an opening at the bottom. But I don't want that. I want to shell the whole body. So to do that, instead of selecting a face, you just grab the body from here over on the left-hand side, like so, and then you shell the amount you want. Now, I have to consider how to do this, pattern. So I need to consider my shell thickness carefully to match up with my slicer settings I'm going to show you in a second in PrusaSlicer. So I want 1.2 because that's going to add up perfectly with my 0.2mm layer heights. So I'm going to do 1.2 like so, and it looks like nothing's changed. However, if we grab the cross-sectional tool, which I've showed in my previous video about 5 quick tips for CAD, you go inspect, section analysis, drop into section analysis, you can see here that we have actually hollowed that object out. So we've got our hollow object, and now we just need to do a cut to make it into our tray shape. So I had this in my mind at the start of the modeling process, which is why I left it as a block so I could cut away the material I didn't need at the end to make my final resin tray. And I did that using a sketch simply on the ZX front plane. And you can see the sketch here. And this sketch is simply a rectangle with a fillet added, so a sketch fillet. And I added another little rectangle here just to remove some material from this point here. And then I did an extrude cut. And it just removed that material. So if you guys, again, aren't familiar with how an extrude cut works, I'll show you here. Instead of adding material, it cuts it away. And because this object's already hollowed with the shell command, it's cutting away just those hollowed edges, leaving us with a nice looking resin tray, quite frankly. So this leaves us with this really nice indented object. It's really quite nice aesthetics. That wasn't that difficult to model. We modeled on the original solid shape and then hollowed it with the shell command. Now, just a few things I did after this is I didn't like these sharp edges at the top, so I just added a simple fillet there. And I can check the wall thickness at the bottom because that's most important for making our little infill sort of hack for a sieve kind of thing. I can go to measure, select the inside bottom face and the bottom face, and you can see here 1.2mm, which is critical for lining up with our slicer settings. So we're done here. Save your resin tray as an STL file, and then we're going to jump into PrusaSlicer. Alrighty, here we are in PrusaSlicer. I'm probably not running the latest one, sorry Joseph, but it works really good, so I'm using it for the tutorial because reliability is more important to me. Anyway, here's what you're going to end up with. You're going to want the infill to be completely exposed, and we're going to use it as a kind of sieve or a mesh to keep our resin parts within the tray when we are dumping them in the isopropyl alcohol to clean the excess uncured resin off. It's actually surprisingly easy to do, but implementing and executing on the 3D printer can be a little bit tricky, as I found out. But let's just go through the actual slicing settings you need to change. So under your print settings, under your layers and perimeters, really all you need to do is make sure that you have your layer height lining up perfectly with your thickness. So remember, we chose 1.2. So we've got a 0.2 millimeter layer height, and that lines up perfectly. We'll get 6 layers within that. And then the horizontal shells, top and bottom, need to be set at 0. Which means it's not going to do any shells at the bottom, it's not going to do any at the top, it's going to leave the infill completely exposed. Now, what infill should you use? Well, I found what works best for me is rectilinear at 20%. You can add more, so make it 30, it's a denser mesh. Lower will make a lighter mesh, but as you go lighter, it makes the infill a lot weaker, so it might not be as good and reliable for daily use. Gyroid might work. I haven't tried it. You only got 6. You only have 6 bits of infill, so gyroid might not have enough time to establish. Rectilinear works good for me. But you can mess around with this if you want to see what works better. But then the final thing you might want to consider is the infill extrusion width. So if you go under advanced, you can start changing extrusion width. Now, first layer 150, that's sometimes 200% depending on what slicer settings you're using. I reduced it a little bit here, but the most important setting is here, infill, and you want to see what extrusion width works well for you, and thicker is better. You don't want to go with 0.4 with a 0.4 nozzle, it's going to be pretty thin. I've gone with 0.5 here. You could even try 0.6 if you're going to 0.4 nozzle. It'll make a thicker, stronger infill, which means a thicker, stronger mesh for the end product. I've also got 3 perimeters here. If you find that your model has gaps where there's infill further up, then you might want to increase this or decrease it depending on what you've got and what your design is. But this slices for me really well. There's no issues at all. But let's just say that you did find that you needed to have infill at the top, but you didn't want it at the bottom, then you can use a modifier. So if you're not familiar with using modifiers in PrusaSlicer, let me very quickly explain it. It deserves its own video. You grab a primitive which intersects with your model, and then that primitive defines a different setting. So, for example, if I right-click this and I say add modifier, and I grab like a box, for example, and I just change the size of this box to be, let's say, like 30 by like 150 by like 40, whatever, and I move it around to here. Actually, let's go with here just for a good demo. Okay, so let's say this part I didn't want exposed infill. Let's say I wanted this part to have the top and bottom shells to make maybe this part a bit stronger. So you select the modifier, and now if you click this little gear, you can start changing things. So under this modifier, it adds its own rules. So let's say with layers and perimeters, I can say down here, it's 0 currently, I want it to actually be 3 and 3 again. So let's say I want this area to have that rule. And you can see in our preview that where the modifier is, it's actually added back in our top modded fill. It's only 1.2 millimeters thick, remember, so that's going to be 6 solid layers. But it's a really powerful way to change various areas of your model very selectively and in a controlled, precise manner. And I don't think enough people use it. I will do another video in future on modifiers in PrusaSlicer. But anyway, I'm just going to send my current model, the G-code, to the printer, and we'll see how we go. But before we proceed, just a quick word on what filaments you might want to use. Now, we are washing our resin prints in isopropyl alcohol, so ideally, at least in my opinion, you want to print with PETG. The issue for me is none of my printers are printing this well at all currently. I don't know why. This is the first test I did on the Sidewinder X1, and it took an awful long time to get it to stick to that ultra base. And then now I've tried to print the new one, and it's just not extruding, and it's like the bed level's changed overnight, even though I haven't touched it. It's really weird. So unfortunately, I'm having a lot of issues with PETG, so I'm going to print this next version in PLA, which in theory should also be resistant to isopropyl alcohol, though we may see some leaching of color. I'm not sure. I'm going to give it a test, but yes, ideally, print this in PETG, or you could probably get away with PLA if you don't mind it probably discoloring or becoming brittle over time. I would probably try to avoid ABS, but PETG, ideally, PLA, probably still fine. Oh lordy, this place is still such a travesty. So I was going to print the final one out on the Prusa i3 multi-material upgrade version 1, which actually still works great. The first extruder is a bit worn out, but the second one's fine. But it's got, like, I don't know if you can see, it's got PLA stuck in it. You know how PLA just breaks over time if it becomes brittle and snaps and bodens. So that's frustrating. So what I decided to do is chuck it onto the, step over the pile of cardboard, the Creality CR10 V2, which I'm currently testing out. So I just chucked the Prusa multi-material upgrade code onto the CR10 V2, and it's printing great. It's over extruding a little bit, which is probably some weird flow setting thing difference, but honestly this part's for strength and utility, not for looks. And check that mesh out. So you can see how it's done that perfect first mesh, first layer with six layers of 20% infill without any top or bottom shells. So I'm going to let this finish, and that's my final version. But I'll show you what's going on with the Sidewinder X1. So some of you guys might remember I had the issue with the cable. Apparently they're sending a new one. But look at this, it's just, it printed one perfectly, and now it's just making these wispy, crappy bits. Like, I don't know if I've flogged the extruder, I don't know if there's something going on in there, but it's just absolutely, like, you can see, I've really tried to stick it down. There was, glue stick with isopropyl alcohol to really spread it out. 90 degrees, I tried it, before without glue stick on just a clean glass bed. It just wasn't working. I don't know what's causing the first layer to be so inconsistent. I don't know if it is that sensor. It's not a micro switch, it's like a proximity sensor. I don't know if that's inaccurate, especially when there's temperatures involved. But yeah, so that's annoying. So that's why my final one is in PLA, not PETG, because the PETG was proving to be an absolute butt. Alright, so this is my final version in PLA. As I said, PETG was starting to give me all sorts of problems. So PLA it is, we'll see how long it lasts. And it's actually really tough. That extra sweep around the outside to give it some rigidity works really well. You can see my earlier PETG version is a lot more floppy compared to this one with that reinforced ridging. Anyway, so what I'm going to do is grab this. I've got some prints done on my 3D printers. I'm going to fill this up with isopropyl alcohol, pop the prints in from the resin printers, and let's see if this works or if it dissolves or how it goes. Okay, so what I have here is the print of the Elegoo Mars. This is a holotape model I found on Thingiverse, which I then hollowed out in Cheeto Box and added some big drainage holes. So this is our little tray. This is the PLA version. And this is our tub. Now, I have heaps of IPA left over from the form review. They sent like an absolute ton. So we're just going to add it all into our box. I'm wearing my safety glasses and appropriate gloves and safety attire. You should always be careful when working with resin prints, and you notice I'm working on this plastic sheet. This is to keep all the resin and nasty stuff off my floor. I can replace the sheet easily, I can't replace the floor easily. So get the scraper blade, just going to pop this off the bed here. There we go. That's why you always scrape away from yourself. We'll grab this, we'll grab a little tray, pop them on, and pop it in the bath. Well, first issue there is it floated, but now it's fully saturated. Not sure if you can see that, there you go. So getting the size close to the container clearly is quite important. Is the liquid going darker colored? Possibly. The PLA might be dying. Is it going darker? No, that's just because of the tape. All right. That's why you have the drop mat. Don't care about spilling a bit of isopropyl alcohol. Totally fine. So, just going to do this a bit. And eventually, if this gets dirty, what you might want to do is have two different baths. So you might have one for the dirty IPA and then one for the cleaner IPA. And yeah, quite frankly, seems to work pretty good. I mean, ideally, you might want an ultrasonic bath. I know a lot of people recommend that, but for what I'm doing, I honestly think that cleans up pretty nice. This tray helps me take it out cleanly and I can go put it outside in the sun to cure. Well, that's going to do it, guys. Thank you so much for watching. This is a really great experiment, and I would say a successful experiment. Apologies for spilling a lot of isopropyl alcohol on my drop mat. I know a lot of you are going to comment on that. Don't worry, it literally is there for that reason. If you did enjoy this video and want to see more projects, things, tips and tricks on Maker's Muse, hit the subscribe button. I would absolutely love to have you on board, and I will be uploading this file as a .3mf, which you can drop into your PrusaSlicer, and it will understand the settings I loaded in. Keep in mind that the printer you choose will have to be very well leveled, and you'll have to do a few other tweaks to the settings to make it work on your specific machine. But I had it working well on the Creality CR10 V2, in PLA at least. PETG, maybe not so much, but you might have better luck. And I'll look forward to seeing you again very shortly. Catch you later, guys. Bye.